10, 43. My bad. The dot. And then we'll talk about this when we get back from lunch. I'm one. Cameron worked out this one. Correct me if I'm wrong with anything I'm going to explain. So Cameron added 10 to both sides. Got -2. Subtracted 6x to both sides. Got -2. And then divided both sides by -2 to get 1. So if you got 1, that was the correct answer. I'm going to quickly do number 2. So when you distributed, some of you may have left it as 15/6, -15/6, which is fine. You can simplify that though. We can combine like terms on the same side. And then move things to the other side. So some of you move 5/2 over. And then added 7. 1 plus 5 gives us 6/2. Some of you went ahead and figured out what that is simplified, which would be 3. And then divided both sides by 3 to get 6. So if you got x equals 6, that was the correct answer. Questions on 1 or 2? For number 3, it was already solved for you. He could have stopped here at 6 equals 4, but then he kept going. It doesn't matter. What type of answer did he get? Alex? No solution. And how do we know that?
Because 0 equal anything is no solution 0. That's the best way.
So there's a couple ways you could write what you know. Make sure you guys are listening. 1 could be that 6 doesn't equal 4, or when they kept going, 2 doesn't equal 0. Either of those would be an acceptable answer. They could have also stopped at this rule because the coefficients are the same, but the constants are different, and because of that, it would be no solution. So either of those reasonings would be fine. Questions on that one? Number 4, I'm not going to go over, but if you want to try that, it is a challenge question, so you can try that on your own. Everyone should have notes that look like this in front of them. I'm going to have you fill in this first part. So the steps to solve absolute value equations. Number 1, make sure the absolute value expression is isolated. What does that mean? To be isolated. Matthew?
Solo.
Solo by itself. It needs to be solved completely by itself. And then step 2, set the inside equal to both the positive and negative number from the other side of the equation. We'll talk about what that means here in a second. Step 3, solve both equations. And then step 4, write your answer as a solution set. So the solution set part might be new to you because that's usually something we do earlier before we see this, but we'll talk about it. Really, it's just you're using these curly brackets to say this is your answer. Everything that falls inside these curly brackets are part of your answer is really what that means. Once you have that all written down, we're going to try number 1, and then we'll go through and do not all of these, but a good amount. Anyone still writing this down? So let's start with number 1. So we have to isolate the absolute value bars. Make sure there's nothing around them, and in this case there's not. If there isn't anything around the absolute value bars, you're going to take the inside, whatever's inside those, drop the absolute value bars, and set this equal to a positive and negative version of this. Absolute value measures distance. So because it measures distance, I can go forwards and backwards. So when we find what it equals a positive and negative number. If these were actual equations, we would solve them and then figure out what that equals. But in this case, we didn't have to do that. So then you would write them in curly brackets, least to greatest. And that would be your final answer. Alyssa. Think about this. This is a curly bracket. Mine just don't look like curly brackets. Other questions on that one? Alright, we're going to move on to number 3. Same thing. Make sure the absolute value bars are isolated, so we need nothing around there. Right now there isn't. We will get to some that are. So then we can set the inside equal to a positive and negative version of what it equals. And we're going to solve both of these by dividing. And then once you have those both in curly brackets, -8 and 8. So make sure you are putting curly brackets and not parentheses, because this is not an ordered pair. Questions on that one? Five is the next one we're going to try. Same rules. There's nothing outside of the absolute value bars, so we can set the inside equal to 8 and -8. And how would we solve for D? Subtract 1. So this would give us what? Nothing.
D equals 7.
And -9. So sometimes the numbers are the same, just one's positive, one's negative, but sometimes that's not the case. So it depends on the problem. So least to greatest, that would be -9 and 7. Questions so far? We're going to try number 7. If that's your phone, go to silence it, please. Okay. So same as before, the absolute value, we need to make sure it's by itself. There's nothing outside of there, so we can set the inside equal to a positive and negative version. And solve both equations. Subtract 2. And divide both sides by 4. What would our two answers be? Okay. Thank you for checking. Hannah? 8 and negative 9. So least to greatest, that would be negative 9 eighths. Questions so far? Once you have this written down, move on to number 9 on the back. Can you make sure you're writing this down? In this box over here, isolate the absolute value bars. So the same step that we've been saying all along, but now we're actually going to do it. So we're going to treat the absolute value bars and what's inside as like a variable. We need to get that by itself, everything else away from it, and then once everything else is away from it, then we'll deal with what's inside. So how would I solve this? How would I get rid of the 2? Victoria? So notice that I'm keeping the absolute value bars. Now I've isolated it. Now I can set it equal to a positive and negative version of this number. And drop the absolute value bars. If you wanted to, when you write your solution set, you could write it like this. This is plus or minus. This is what that symbol is called. Instead of writing it out, negative 10 and positive 10. But you can write it either way. It doesn't matter. Don't write it both ways, because you don't need that. Do we have any questions on that one? We're going to do a few more, and then any problems you want to see, go over, have questions about, we'll do those. Skip down to, what number did I say? 12. There's a negative 2 outside of the absolute value bars. We need to get rid of it. How would we do that? Yeah. Okay. If that negative 2 was behind it, then yes, we would definitely add. But it's right next to the absolute value. Alex, I did see your hand. Not distribute, because we don't want to do anything inside. Victoria, what were you going to say? Division. Division. Because these two things are multiplying to each other, so we're going to get rid of the negative 2 by dividing. I mean, is that what you were going to say too? To if you have something next to, we're not distributing because technically the inside doesn't exist right now. We're pretending it doesn't exist until the end when we can actually solve it. So now there's nothing outside of the absolute value bar, so we can take what's inside and set it to a positive and negative version of this number. If you did distribute, that would be the wrong step. You would not get the correct answer. And then subtract 3 to everything. So your solution set should be negative 10 and positive 4. Any questions on that one? We're going to skip down to number 15. There's a lot of things going on there. What do we think we would do first? Colleen? We are going to divide by 7, but we're not going to do that first. Only because if I did that, I'd have to divide this and this and this by 7, and we might end up with fractions which we don't want. Cameron?
Add 16.
So after we add that 6, now, Colleen, we can divide both sides by 7. Do that and tell me what you get. Hannah, 16. What would be our next step? Victoria? Drop the absolute value bars and do what with it?
And 4n plus 8 equals 16. 4n plus 8 equals negative 16.
So notice that we have the absolute value bars until a certain point, and then we no longer have absolute value bars. You need to do the same thing as you're working. And then solve both. If you need more space, you can use this space over here. So if you got negative 6 and 2, good job. That was the answer. Do you have any questions on that one? Okay. For number 17, there are some special cases with this. If you get an absolute value equation where from the start this equals a negative number, like your absolute value is isolated, there's nothing else you can do, and it equals a negative number, we cannot solve this because absolute value is supposed to measure distance. I can't have a negative distance. So this would be a no solution. You would not continue solving this. You would stop. Now, there are some that won't look like a no solution until you solved it or isolated the absolute value. And then there are some that will look like it might be a no solution, but you have to isolate and make sure it's not. So let me show you both of those examples. For this one, if we started to solve this, we would divide both sides by negative 3. And as we divide, what it equals is now a negative. Because it's now a negative and there's nothing else I can do on the outside, I can no longer solve this. There's no solution. But there was an example we just did where this started off as a negative, but as we were isolating, the negative went away, and that was okay, so we ended up with a solution. But if you isolate it and there's still a negative over here, we cannot have a solution. Right? And the explanation for this is this. Absolute value cannot equal a negative number once isolated. Once you have that written down, look through the problems we did not do, / the next page, front and back. Find any questions you want to see, go over, not sure where to start, have questions about anything like that. Camera. 13 on the problems we were already on. Okay. Anyone still writing this part down? Okay, so we have 13. Any others we want to see, go over, have questions about? Sophia? 16. Saw another hand, but I didn't see who it was. We have 13, we have 16. Any others? 7 on the other page. Any others? So we're going to start with 13, move on to 16, and then do 7. And then I'm going to show you a couple things on what your Khan Academy for this Friday is going to look like. Right. For number 13, we need to get rid of the 6. What would we do to it? Go ahead. Multiply both sides by 6. So then the 6's would cancel on this side, just leaving the absolute value of 2w minus 4. Then it becomes a regular problem. Drop the absolute value, set it equal to a positive and negative. And solve both the equations. So if you solve this, what does W equal? What would we get? Victoria.
-7 and 11.
Questions about that one? For number 16, what would we do first? Victoria, go ahead.
Add the 24 to 21.
So we have 3 over 2 times our absolute value equals 3. Then what? Victoria?
Divide 3 over 2 by, divide 3 over 2 by 4 r to.
So yes, you can divide this on both sides. What else could we do instead of dividing by a fraction? Something else. Instead of dividing by that fraction, we can do something to it and do a different operation. Hannah? Say that again. Multiply by the reciprocal. Take this number and flip it. And multiply that on both sides. So if we did that, this would become 6 over 3, which is just 2. The 3's we really just cancel. So then you can set this equal to a positive and negative version. And solve. In this example, you're going to get fractions. Sometimes that happens. If the fractions are nice decimals and you want to put them as decimals, that's fine. If they're repeating decimals, leave them as fractions. If you leave them as fractions, make sure you simplify. So then our solution set, one of these should be negative. I feel like 6, 2, maybe not. If you're not sure which fraction is higher than the other, you could put it in, not in alpha y equals, just in the calculator. This would give you 1.5, this would give you 0.5. So least to greatest, it would look like that. Questions on that one? And then number 7. Is the are the absolute value sure? Are the absolute value bars already isolated? Yes. So that means we can move to the next step, set the inside equal to a positive version of this and a negative version of this. And solve both equations. Multiplying by the reciprocal here might help you a lot instead of dividing everything by fractions. So if I take this and I flip it, that would be 2 over 1. So I'm multiplying both sides by 2. So negative 16 and, I'm sorry, negative 36 and 16 would be your final answers. Any other questions that we wanted to see, go over, weren't sure how to start? have this written down, on the back of your quick check page, I'm going to have you write this down. Come back to this. Write both of these down. On the back of your quick check page, write both of these down. So the first one is -2 times the absolute value of x minus 14 plus 5, equals -6 times the absolute value of x minus 14 minus 1. And then the other one is -7 times the absolute value of x plus 1 minus 5 equals 2 times the absolute value of x plus 1 minus 5. So these will be what you see on Khan Academy. It's different than what we were just doing, but I'm going to show you it's not that much different. Because right now, you should see that the insides of the absolute value are the same on both sides. You won't get things that aren't the same. So when these are the same, you can treat these like a variable. You're trying to get variables to the same side, constants to the other. That's basically what you're doing here. You want to get one of these combined with the other. Doesn't matter which side you do that to. So let's say I move this and add this to the other side. Just like when we combine like terms, we are only really combining the coefficients, not the x's. Same thing here, we are not combining what is inside. That will stay the exact same. This side will cancel and just leave -1. So now it looks more like the problems we were just doing. So I'm not going to continue to solve this one because I want you to try it, but we are going to do the next one. Before we do the next one, do we have any questions on this one? So for the second one, same process. We need to get the insides on the same side. Doesn't matter how we do that. Which one do we want to move? The 2 or the -7? Doesn't matter. Okay. So then we would be adding 7 over. This entire thing would cancel, just leaving -5. This would be 5 times x plus 1 in the absolute value, minus 5. I'm sorry, that's not 5, that's 9. And then if we solve this, what would we do first? Hannah. Not first. We will get rid of the 9, but not first. Look back at the examples we just did. What would we get rid of first? Go ahead, Alyssa. Add 5. What's going to happen when we add 5 though? We're going to get 0. That's okay. So then if we get rid of 9 and divide the Is that going to change? No. It's still going to be 0. So when we go to set it equal to a positive and negative version, 0 doesn't have a negative and positive, so you're only going to set it equal to 0, and that's it. And you're just going to have one answer when you solve this. So with absolute value equations, you can have one solution, you can have two solutions, or you can have none. You cannot have infinitely many in this case. Do we have any questions on that? So for the remainder of class, you have 3 options of what you can practice. You can go back through the notes, do the rest of the problems, work on those, and practice those. You can work on the one Khan Academy on this that's due Friday to get it out the way. If you finish those or want to do something else, I have a absolute value scavenger hunt that leads into the hallway that you can work on, but you have to come see me to get those papers. So you can be working on any of those, but we should be actively working. Yes, Adam. Not right now. On the 21st is your next flex day. That's retake stuff. Right? So be working on one of those 3 things. If you have questions, I'll be around.